Assalamu alaikum and welcome to e-learning Al Noor International School, grade 10 chemistry course. I'm your chemistry teacher Faraz Anjum. In this week we will study chapter number 13 state of matter, lesson number 4 changes of states. For this reference we need the textbook page number 436 till 439. So please open the page number 436. This week in this lesson our main objectives are identify the condition necessary for sublimation and determine how the conditions at which phase are in equilibrium are represented to the phase diagram. Let's start with the sublimation. When can sublimation occur? For this, what is sublimation first? The change of the substance from a solid to the vapor without passing through the liquid state is called sublimation. Directly from solid to the gas or vapor. Okay. So sublimation can occur because solid like liquid have the vapor pressure. Sublimation occurs the solid with the vapor pressure that exceed atmospheric pressure at or near room temperature. Okay, so solid directly become vapor sublimation, and vapor become directly to the solid. This is called deposition. Iodine is an example of substance that undergoes the sublimation. The outer test tube contains the solid iodine that is being gently heated. The inner test tube contains the liquid water and ice. The iodine crystal at the bottom of the outer test tube change directly to the iodine vapor. When the vapor reaches to the cool surface of the inner test tube, it goes directly from a gaseous to the solid state. Okay, so you can see here, this is the purple is iodine. Inside here as well it can directly convert into from solid state to gaseous state. Sublimation has many useful applications. Solid carbon dioxide dry ice is often used as a coolant for goods such as ice cream, which must remain frozen during the shipment. So because of the sublimes, it does not produce a liquid as ordinary ice does when it melts. So as it changes the state, dry ice absorbs the heat, keeping the material nearby the cool and dry. So which of the following decreases a solid and undergoing sublimation? So vapor pressure exceeds the atmospheric pressure. Now the most important thing is phase diagram. What is phase diagram? How we interpret. So how the condition of the which phase are in equilibrium represented on the phase diagram. So let us start with this. The relationship among the solid, liquid and vapor state or phases of the substance in a sealed container can be represented a single graph. This graph called phase diagram. Okay, so the representation of the solid, liquid, gas or phases in the single graph is called phase diagram. A phase diagram gives the condition of the temperature and pressure at which the substance exists as solid, liquid or gas, which is vapor. So let's see this. The condition of the the condition of pressure and temperature at which two phases exist in equilibrium are indicated on the phase diagram by the line separating the phases. Here we go. You can see here the phase diagram of water shown the relationship among the pressure, temperature and the physical state of water. In each of the curving regions of the phase diagram, water is in a single phase. You can see this indicating the solid, okay, this indicating the liquid and this indicating the gas or vapor. So look, it's covering here from here to here. These are the gases. From this part, this is called liquid state and this one is solid state, and these indicating the pressure. You can see this is 101.3 degrees Celsius, and this indicating the temperature. So from 0 till 100 degrees Celsius. So you can see if you go for the 0 directly on the top at this point at 101.3 degrees Celsius, this the point is called freezing point or melting point for the ice or water, you can say. Okay, so if you increase the heat or temperature, this ice which is solid become liquid. If you freeze it more, it go there, okay, to become solid. So this line separating the state which is or phase solid to liquid. Now observe here 100 degrees Celsius, this is temperature. Okay, so when you go for the temperature on the top at this point which is 101.3 kilopascal, the pressure at this point, this is ground level, okay, sea level, you remember this. On the sea level at 100 degrees Celsius, what will happen? The liquid become vapor. At this point, what will happen? The liquid, which is water, is a normal boiling point of water, okay, so it become vapor on this way. So this line indicating that this liquid become vapor on this stage, on this pressure. Now if you decrease the temperature, means when you go with the elevation, you can see the temperature to become vapor decline. When you lower it down the pressure, so it means more declining, okay, and liquid become vapor. So that's how you're going to interpret it. So one by one start. So the curving line that separates the water vapor phase from its liquid phase describe the equilibrium condition of the liquid and vapor. So see this, as I told you, this line indicating the equilibrium condition. Next, the other two lines describe the conditions of equilibrium between the liquid, water and ice, and between vapor and ice. So see this one, ice and water, and then ice and vapor, like this. Now the point on the diagram at which all three lines is meet called triple point. So here this is called the triple point, okay, where all these three lines merge. So the triple point describe the only set of conditions at which all three phases can exist in equilibrium with one another. So for water, the triple point is a temperature of 0.016 degrees Celsius and a pressure of 0.61 kilopascal. Okay, so what is it? 0.016 degrees Celsius, remember, for the triple point. In the flask, okay, this flask is in a triple point. Freezing, melting and boiling and condensation are all occurring at the same time in the flask. Describe how water might move from Earth's surface to the Earth's atmosphere and back again as a part of the water cycle. Be sure to include any phase change that occurs in your description. Liquid water evaporates from Earth's surface and rises to the atmosphere. There it forms cloud and condense as rain that fall back to the Earth's surface. That's why it's water cycle going on. Okay, by referring to the phase diagram of water, you can determine what happened if you melt the ice or boil water at the pressure less than 101.3 kilopascal, as I told you here. Okay, when you go decreases, okay, so decreases the pressure, lower the boiling point and raises the melting point, and increase the pressure will raise the boiling point and lower the melting point. So below the triple point, the vapor and liquid cannot exist in equilibrium. Increasing the pressure won't change the vapor to the liquid. The solid and vapor are in equilibrium at the temperature below 0.016 degrees Celsius, with an increase the pressure and vapor being to behave more like a solid. Okay, for Earth, the accepted hypothesis for how ice skaters move along the ice was the following. The blades of the skates exert the pressure which lower the melting point of the ice melts, and a film of water forms under the blade of the skate. This film acts as a lubricant, enabling to the skaters to glide gracefully over the ice. Wide skis exert much less pressure per unit area of snow than the narrow skate blade exert on the ice. Recent research shows that the surface of the ice has a slippery, water-like surface layer that exists well below ice melting point. The liquid-like surface layer provides the lubricant needs for the smooth skating or skiing. Describe the melting point of a line in a phase diagram. Along the line is a phase diagram. Two phases are in equilibrium with each other. Thank you so much. That's all.